In previous mathematics courses, you have studied solving simple exponential equations based on the idea that a raised to the x equals a raised to the y if and only if x equals y. In this section of your assignment, you will be applying the same logic to logarithmic equations. Log base a of x equals log base a of y if and only if x equals y. Two examples are provided for you in your assignment. Make sure to look at these examples before working on the problems. Here's an additional example. Rewrite the following equation so that you set up a one-to-one correspondence between all of the parts. Then solve for x. Log base 2 of 3x over log base 2 of 39 equals 1. We want to rewrite the equation above so that it looks like log base a of x equals log base a of y. Right now we have both logarithms on the same side of the equal sign. We need to move one to the other side so we can solve for x. We can do this by multiplying both sides of the equation by log base 2 of 39. Since log base 2 of 39 over log base 2 of 39 equals 1, we end up with the following equation. Log base 2 of 3 times x equals log base 2 of 39. Then, based on the principle stated earlier, 3x equals 39, so x equals 13. In the task you did today in class, Logarithmetic, you learned that using the three logarithm rules learned previously, you can find the value of logarithms. Remember, the three logarithms rules are log of a product rule, log base b of x times y equals log base b of x plus log base b of y, log of a quotient rule, log base b of x over y equals log base b of x minus log base b of y, and log of a power rule, log base b of x raised to the k equals k times log base b of x. Using these rules, we can break down logarithms of larger numbers for which we don't know the value into logarithms of smaller numbers that we do know. As you are trying to break the larger numbers down into smaller numbers, here are a couple things to try. Keep the base of the logarithm in mind, since you will be able to calculate the value of logarithms of the powers of the base easily. Breaking large numbers down into their prime factors may be helpful. Consider powers of numbers for which you will be able to use the log of a power rule. For example, use the given values of the properties of logarithms to find the indicated logarithm. We are given that log base 2 of 3 equals 1.585, log base 2 of 5 equals 2.322, and log base 2 of 7 equals 2.807. For our first logarithm, log base 2 of 20, we want to start by breaking 20 up into factors that we either know the logarithm of or that are powers of 2. We know that 4 times 5 equals 20, so we can use this and the log of a product rule to help us find the value of log base 2 of 20. So, log base 2 of 20 equals log base 2 of 4 times 5, which we know equals log base 2 of 4 plus log base 2 of 5. We were given above that the log base 2 of 5 equals 2.322. We also know by the definition of a logarithm that log base 2 of 4 equals 2, since 2 squared equals 4. Therefore, log base 2 of 4 plus log base 2 of 5 equals 2 plus 2.322, or 4.322. For our second logarithm, log base 2 of 9 over 35, we can see right away that we can rewrite this logarithm using the log of a quotient rule. Log base 2 of 9 over 35 equals log base 2 of 9 minus log base 2 of 35. Because we don't know the value of these two logarithms, we need to break down each number further. We know that 3 squared equals 9 and that 5 times 7 equals 35, so we can use this to replace the numbers in our equation and then use the log of a power rule and the log of a product rule. So, log base 2 of 9 minus log base 2 of 35 equals log base 2 of 3 squared minus log base 2 of 5 times 7, which is equal to 2 times log base 2 of 3 minus log base 2 of 5 plus log base 2 of 7. We can now use the given values to find the value of our original logarithm. So 2 log base 2 of 3 minus log base 2 of 5 plus log base 2 of 7 equals 2 times 1.585 minus 2.322 plus 2.807, which gives us 3.17 minus 5.129, or negative 1.959. Previously, you have learned the following definition for a logarithm. For all positive numbers a, where a does not equal 1, and all positive numbers x, y equals log base a of x means the same as x equals a raised to the y. In this section of your assignment, you will use this definition to help you solve logarithms with a base of 10. For example, use your calculator and the definition of log x, recall that the base is 10, to find the value of x in log of x equals 2.45. We use the definition of a logarithm to help us rewrite the equation as an exponential equation. So, log of x equals 2.45 equals 10 to the power of 2.45 equals x. Now to find x, we simply need to enter 10 to the 2.45 into our calculator. So x equals 281.8383.